HET 273, Pneumatic, Electric, and DDC Automation. Week 2, HVAC Systems. This week's assignments will support the HVAC learner to understand heating systems, understand cooling systems, understand humidification, understand ventilation systems, gain knowledge of economizer systems, describe air handling units, understand air handling systems. The HVACR industry uses boilers, chillers, air handlers, rooftop units, economizers, and duct systems to provide heating, cooling, and ventilation air throughout a building. Therefore, a HVACR technician must have an understanding of these systems to maintain control in order to achieve the desired outcomes. This week's vocabulary: variable air volume, constant volume, dampers, economizers, indoor air quality, IAQ, boiler, chiller, heating coil, cooling coil. Heating systems. Every structure or building needs a method to maintain temperature and comfort during the winter or when the weather is cold outside. These heating systems use hot water, steam, forced air, or electric. Forced air systems are normally small rooftop or residential furnaces which are used in smaller structures to maintain the temperature. Electric is used as auxiliary heat, baseboard heat, or as a reheat in a large air handling system. Steam is used in older systems or large industrial systems, sending steam out to buildings which have heat exchangers and convert the steam into hot water. Most buildings today do not use steam boilers as their source of heat. Today, hot water systems are by far the most widely used heating system available. It is economical, easy to maintain, and clean to operate. It has very little problems or maintenance issues. In this picture you see a gas-fired hot water boiler. Hot water boilers, or any boiler, whether it's steam, forced air, use gas or oil or even electric to heat them. The hot water boiler uses a piping system and pumps and a coil. The water is circulated via the pump through the coil to provide heat to the duct systems, which then transmits that heat into the rooms as required. Cooling systems. Outside air economizer or free cooling. We start with this system because this is a system that is widely used in all commercial applications, where we have outside air brought into a building to provide free cooling during the times when the temperature is applicable. Normally any temperature below 65 degrees. We therefore use this free cooling and economizer air to cool our structure. How this works is we take the outside air through the supply air fans, draw it into the building, therefore sending it down the ductwork to the spaces to be used for cooling as required. The air is then brought back through the return air system and is either brought down through the return or mixed air dampers or is exhausted from the building. Cooling systems, direct expansion. These use refrigeration systems, have low coil temperatures, but are limited in distance from the air handler due to refrigeration lines. These systems are very popular in smaller types of buildings and used in rooftops or in residential systems to cool the buildings. They can be used for specific locations such as computer rooms or rooms that require a special cooling need other than the main building structure. Cooling systems. Chilled water. Chilled water systems are very popular in commercial buildings. They provide adequate cooling by using a chiller, piping system, pumps, and chilled water coils. Below you see a centrifugal chiller. The chiller takes water from the building, circulates it via pump and piping system to coils, bringing it back and recirculating again. It gets its cooling from the compressor. The compressors used are centrifugal, rotary, screw, reciprocating style compressors. A chiller also has a condenser bundle which takes water, circulates it through a cooling tower to reject the heat to the outside, then bringing that water back to the building to be recirculated through the condenser to maintain the condensing temperature. These systems can go from small chillers to very substantial chillers or multiple chiller systems to maintain the building's cooling load. Ventilation systems. Ventilation systems use outdoor air, return air, and exhaust air. In the graphic here we see the 3 dampers used, along with a special minimum air damper. We use the outside air damper to bring ventilation air into the building. It also is used to bring in the free cooling through economizer operations. The minimum air damper is used when we're outside economizer range and is used specifically to bring in the ventilation required by code to maintain occupant comfort and safety. The mixed air return air damper is the damper that allows the return air from the return air duct to return back to the supply side, or it closes off and pushes that air towards the exhaust damper, which expels it from the building, thereby working with the outside air damper to maintain the static set point in the building. These systems are popular in large buildings as well as economizer systems on small package unit rooftops. The exhaust air. Exhaust air dampers are used to prevent pressurization. When bringing in outside air for either ventilation or for free cooling, that air, once it enters the building, has to have some place to go. If it has no place to go, the building will begin to pressurize. If you've ever noticed a building whose entry and exit doors are pushing outward, or you feel a rush of air passing you as you enter the building, what that's signifying is the fact that the building is overpressurized and we're not moving enough air from the system. Most of these supply and return systems have what we call a lead-in lag, meaning the supply air runs at a certain speed to maintain air, and the return air runs at a little bit less speed, thereby allowing for kitchen exhaust, bathroom exhaust, or other items that need to be exhausted from the building to be released from the building without affecting the static pressure of the building. So at the end, air needs to come in the building and be exhausted out of the building evenly to maintain the static of the building, so it's not in a positive pressure or a negative pressure. Ventilation system operation. The ventilation system brings in the required outside air for building needs, exhaust air based upon static set points, mixes return and outside air to maintain a mixed air temperature set point, which provides a savings on either the heating and cooling depending on which system is in operation, and it provides the free cooling for the building normally during the spring and fall of the year. Air handling units. Components. An air handling unit is made of several components. It's made of ductwork, fans, dampers, and coils. Also, the air handling unit has several different types of sensors and controls to maintain a safe condition within the ventilation system. In this graphic, we can see there is a supply fan, a return fan, exhaust dampers, mixed air return dampers, outside air dampers, a heating coil, a cooling coil, a pressure reducing station, and sensors. Supply air pressure sensor, supply air flow sensor, mixed air temperature sensor, a filter status, return air temperature sensor, low limit, return air pressure, and we also see the return fan command. There's also a fire alarm status, filter status, and flow status. Most dampers also have, for a fire situation, isolation dampers which isolate it from the ventilation system in and of itself to prevent the spread of fire or to cause oxygen to be moved during a fire. Air handling unit system operation. An air handler uses a supply and return fan to move air through the building. The supply fan moves air into the space. The return air fan draws air out of the space. There are also heating coils, cooling coils in the system to maintain the proper temperature desired at the discharge air temperature set point. There are the three dampers: exhaust, mixed air, and outside air. In this case, we see the minimum damper also used, which is used when we're only using ventilation air, meaning that we're outside of the economizer temperature range. So an air handling system provides a couple of functions. Provides the proper air for the building, provides it at the proper temperature for the building, exhausts the air as air pressure builds up in the building, and in most cases the air handler in and of itself contains the filtration for the building. Most air handlers also have an ability to add humidification to the building as needed. Building air handling systems, constant volume. Constant volume system has 100% fan output, meaning the fan runs at a constant speed, which is all out all the time. How it maintains building temperature is by varying the air temperature. It can use free cooling, it can use a cooling system, and it can use a heating system to attain that. There are no dampers out in the building system other than balancing dampers to maintain the proper amount of CFM in each space. What happens in this type of system is the fan runs, the coils, either if we're in heating season, we put heat into the air to maintain a discharge hot deck temperature, or we provide cooling to the cooling coil to provide a cold deck temperature. In this case, you see the two ducts, one with heat, one with cool, to provide whatever the system needs through each of the dampers. It then will go out to the space and maintain the temperature. These systems are very prevalent out in the field. They are no longer the popular way to go, other than in smaller applications. You will see these in retrofits in larger buildings, but this system is going by the wayside because it is costly and inefficient to operate and does not provide as accurate a temperature control as we would like to see. Building air handling systems, variable air volume. In variable air volume systems, or VAV systems, we have a constant temperature and we vary the fan speed to maintain the temperature in the structure. Normally these systems provide air out of the discharge of the unit at about 55 degrees. The system itself maintains occupant comfort by varying the fan speed. The fan speed is varied based upon the VAV units in each of the rooms. They have dampers in them that will open and close based upon temperature in the room. As the temperature rises and there's a need for cooling, the damper in the VAV box will open, therefore allowing more air to flow into the room and then cool it off. As the room gets too cold, it closes that damper down to a minimum position and maintains comfort. How the fan varies in these units is based upon that damper actuation. As the dampers open, the static in the main air handler will drop, thereby causing the fan speed to increase to maintain that static pressure. And as the dampers close, it will cause the fan to slow down, thereby again maintaining the static pressure in the duct. So in VAV systems, static pressure is what controls the pressure in the duct system. In summary, the HVACR technician must understand how individual system components operate. A technician must understand how components work together to create a system. The technician must demonstrate the use of economizer, free cooling. The technician will describe the operation of a VAV system.